Welcome to this fourth tutorial on 885 programming, and the topic of today is memory. So what if I give you a list of numbers? Say I give you a list of 1000 numbers and I tell you to add them. You definitely cannot do them in your head only. You will require some pen and paper, and then you will take your time to do that. So similarly, these basic registers that we saw A, B, C, D, and HL are not able to accommodate large amount of data, and that is where we require memory. So let us first have a look at what type of memory is available in 8085 and how much memory is available. So click on this tab of memory at the right hand side, and you will see that you have got certain display here which says that there is address written over here in hexadecimal. Means these are the memory locations which you see in every row, and the corresponding address is in hexadecimal and address in decimal system is written here, and the data which is placed at these locations by default is also shown here, which happens to be 0 in our case. So these are the memory locations. Now let us scroll down by dragging this to the bottom, and you can see that there are 999, means from 0 to 999. That is why there are 1000 memory location which are displayed at once. Now is it that only 1000 memory locations are available? No, it's not so. At this start tab you just type 1000, so it will start the memory locations from 1000, and you can see that from 1000 the memory has started, and when you will further scroll down this scroller, so you will see that it goes up to 1999, means from 1000 to 1999 again there are new 1000 locations. So is it infinite in extent? Means are we having infinite memory? So let us check by putting here a very big number, say this number, and when you will hit enter or hit OK, this will say enter a valid number within range 0 to 65535. Means from 0 to this number we have a total of 65536 locations including 0. So these many number of locations are available, and their hexadecimal equivalent addresses are 0H to FFFH. This FFFH is equivalent of 65535. So we can see here that we have a lot of memory locations, and our program which is written here is stored in this memory location together with our data. So let us first convert this number into kilobyte, because we usually represent memory in terms of kilobyte for small units. So let us see how this can be done for binary numbers. So on Wikipedia page you can see that the kilo prefix is for decimal system 1000, and the kilo prefix for binary is 1024. So if I want to convert that number 65536 to kilobyte number in binary, then I have to divide it by 1024. So 65536 total locations were there, they are divided by 1024, and when you will divide it you will get 64. So we can easily see that there are 64 kilo locations, and 64 kilobyte is the total memory size. Now I have written this byte in a different color to signify that every location can store 1 byte of data. Means this data is of 1 byte, and we have 64 kilo such locations. Means 65536 such locations are there from 0 to 65535, and the every location can store 1 byte of data. That is why we have 64 kilobyte memory here. And when you will type 65535 in this start tab, you will see that after this there are no memory locations. So the take home message is we have got 64 kilo locations of memory. Each location is capable of storing 1 byte of data. So now we will see how to handle this memory, how to transfer data from this memory to these basic registers A, B, C, D, E, H, L, and then how to perform calculations and store the data back to this memory. So for that I have written to the start position 0, and I will type a value of 10 here. Now I am giving a data value of 10 at location 5 inside memory. So the way to do this is just double click here and put a value of 10 here. And now I also want to give a data of 5 here. So you can either do this by the same thing, or you can use this tab also. You just put here memory location number 6 and put the data that you want to enter here. Remember that the data that you put here should be of 1 byte only, that is from 0 to 255 only. So I have written here 6 and I have written here 5. So at location number 6 I will be putting a value equal to 5 and then click update memory. So when you will click update memory, you can see that 5 appears here. Now one important point to note is that the data that is displayed here is in decimal form, as against when we are displaying data in these basic registers it was displayed in hexadecimal form, but here the data is displayed in decimal form only, and their hexadecimal equivalents will be taken for calculations. Means, for example, we have written 10 here, so 10 in hexadecimal will mean A. So A will be used for calculation when this data will be imported to these registers. So this is one important point to note. Now I have written this simple code, and the purpose of this simple code is to we will first of all load this data of 10 from memory location 5 to the accumulator register. Then we will copy the data from accumulator register to B register, that is here, and then we will further load a data from memory location 6 which happens to be 5 in A register again, and then we will perform simple addition of B and A and store the result in A, and then that result will be stored to a location, this one 000BH, means the result of calculation will be stored here. So the code for that is here. So let us understand this step by step. LD means load, A means accumulator. Load accumulator with the content of memory location whose address is 0005H. So this is LDA command. This is used to access data from memory to the accumulator, and it is as simple as that. LD is for load, A is for accumulator, and then 0005H. Remember that there is no command as LDB for B register or LDC for C register. This command only works for this accumulator register. So this is used for loading. Now after loading this accumulator with a data which is kept at this memory location, which happens to be 10, and it will be taken as a value in hexadecimal which happens to be A. So A will be loaded in accumulator, and through this command we already know that data from A will be copied to B, that is in reverse direction. So A will give its data to B, and A will also retain a value of A, and B will also retain a value of 10 or hexadecimal A. After this we will again load this accumulator with a value which is kept at 0006H, which happens to be 5 here, and then we will add B, and this add B command will by default add the content of B to accumulator and store the result in accumulator itself. And then ST is for store, and A is the accumulator. So store the contents of accumulator to this memory location. So the result which is stored in A register after this addition will be stored to the memory location 000B and at this particular location, and halt is used to stop the program. So now we will press F5 and we will see the execution of every step one by one. So I press F5, but before that let us save it. So save as, and then I am giving it a name and I am selecting a location. So we have saved it, and now I have pressed F5. So I am at the first location. I will then again press F5. So this data, as you can now see that this data of 10 from location number 0005 is loaded into the accumulator as 0A. Now I am to the second location where I will press F5. It will be executed. So this data from A has been copied to the register B. Then I am again loading this accumulator with the contents which are placed at memory location this 006H, which happens to be 5 here, and after execution, means after pressing F5, this data is again loaded into this register, that is 05 is loaded here. Then I will perform this operation add B by pressing F5 again, and you can see that they are added, that is 0 A and 5 are added to give you 15. 10 plus 5 is 15, and 15's equivalent in hexadecimal is 0F. So it is stored in this A register, and then I will execute this command STA and by pressing F5. So the result from accumulator will be transferred to this particular location 000B, and it happens to be 15, not F, because here the data will be displayed only in decimal format, and halt is used to hold the computer. So in this tutorial we have seen a very simple program of how to access the memory through the accumulator register, although there are multiple ways which we will see in our next tutorials. But the basic is that accumulator register is able to perform data transfer from the memory or to the memory through this LDA and STA command. So memory can be accessed in this way. Also we have seen how much memory is available and how much each memory location can store. So that happens to be 64 kilobytes for 8085 microprocessor. So for more updates, keep watching our channel and subscribe to our channel. Thank you.